this function f is negative and has a domain x is less than 0, if the asymptotes of the graph f are x equals 0 and y equals negative 4, which of the following statements must be true?
Okay, so let's go ahead and make our quadrant. It says we have a vertical asymptote at x equals 0. So here's my vertical asymptote. And also at y equals negative 4. So 1, 2, 3, 4. So I can either be in this region up here on the top right, top left, top right, bottom left. And it says my function is always negative, negative, meaning I have negative x value and negative y value. That leads my function to be right here. And I'm going to actually answer the one that's actually correct. On C, it says, as we approach 0 from the left. So this is 0. This is right, and that is left, correct? So on the left, are we really going down to negative infinity? Yes, we are. And then the limit as x approaches negative infinity, as we go to the left, we get to the horizontal asymptote, y equals negative 4. So if you can draw this image, you should be perfectly fine. Okay, number 2, Kylie, let's read.
The function f is not differentiable at x equals 3. Which of the following statements must be true?
Okay, so that means there is no derivative, correct? So I'm going to jump to one of the conclusion on this one. We know it has to be C because if there's no derivative, this right here is a definition of derivative. So if that is a definition of derivative and it says it's not differentiable, then it's not going to exist. And let's actually look through all of them. Part A says the function is not continuous at 3. Okay? It could be a cusp. And if it is cusp, it is continuous, but not differentiable. And then part B says limit as x approaches 3 of f of x does not exist. This must exist. And then we talked about how it does not go up to Riemann sum. So if you see anything with the integral, do we pick them? Don't even look at it. Okay, number 3, Marissa, let's read.
If dy over dx equals x to the power of 4 minus 4x cubed plus 5x minus 1, then the third derivative,
That's right.
evaluated at x equals 1 is.
Okay, so we need to derive this not 3 times, because what I already have is the first derivative, right? So since this is the first derivative, my second derivative is going to look like this. So x to the power of 4 is going to give us 4x cubed. Any questions on that? The next one is going to give us what? Negative 12x squared. And then the last one is going to give us plus 5. And then I need to derive this one more time. Okay, the first part is going to give me 12 what? X squared. The next one is going to give us negative 24x. Anything else? So now all I need to do is plug in the 1. So when I plug in the 1, we get 12 times 1 all squared minus 24 times 1. And really in the end is 12 minus 24, which is negative 12. Done. Okay, Jason, let's read number 4.
The number of gallons of water in a storage tank at time t in minutes is modeled by W of t equals 36 minus t squared. At what rate in gallons per minute is the amount of water in the tank changing at t equals 4?
What rate? That is the slope. So we're looking at W prime of t. Since we know W of t, we can go ahead and derive that. So W prime of t is going to give us negative 2t. And then all I need to do is plug in t equals how many? So we have negative 2 times 4. And that's going to give us negative 8. And that's negative 8 gallons per minute. All right, Jacqueline, let's read number 5.
Let f be twice differentiable function that f prime of x is less
F double prime.
f double prime is less than 0 for all x. The graph of y equals r of x is a secant line passing through points 2, f2, 4, and 4, f4. The graph of y equals v of x is the line tangent to the graph of f at x equals 3. Which of the following is true?
It's quite a bit of wording, right? So let's break it down one at a time. If my double prime is less than 0, it is concave down. So draw me a concave down wherever you want. And this is the f function.
Did we use our card?
What's that?
Did we use the card during the exam?
No. The next piece. It says graph of r of x is secant line. Now, secant line passes through a 1 point or 2 points? 2 points. So I'm going to say, here's my secant line right here. And that secant line is the r graph. And then it says my v graph is going to be what kind of line? Tangent line goes through how many points? Only one. So I'm going to find one spot where it's going to go through. And let's call this one v. Now let's put in the numerical value then. On my secant line, it says at 2. So this one is at 2. And at 4, this one's at 4. And my r was at some number, graph of 3. This is 3. So are we good with how we number them? 2, 3, and 4. And if you look at the answer choice, what is my x value given right here? 3 point. So would you agree 3.2 is between 3 and 4? So I'm going to go ahead and make a dot all the way through that includes all of them. And ask myself the following question. Which one is the smallest? That is bigger. That's not as big as the first one. This is smallest, correct? So we know R is the smallest. And then what's the next smallest? F. And after F, what's the next one? The largest? V. And which one pertains to that? Boom, done. So if you can draw the image, you're good to go. Okay? All right, number 6. Let's see, Tate, let's read. So we're using what rule when I have a chunk multiplied by another chunk? We have product rule. I'm recording right now. Are you just dropping that off?
Hello, everybody being recorded?
Can you tell them the date, what period, what the year, everything?
No.
Okay.
Today is the 11th of December
Right side
at
forward.
11:41
Go away.
a.m.
Okay.
What? You asked me to do that.
Thank you.
Hey, you're welcome. Y'all have a good day.
Thanks, you
Thank
too.
you.
Number 2 is C.
Boom.
No, don't listen to him.
Uh-huh.
It was C.
Oh, it was?
Go figure.
What do we do with it? Is this a video of the year?
Yeah.
Okay, we're gonna have to give him like the little,
Did y'all
is it the Golden Globe? What do they get? Okay. Okay, let's apply our product rule. Is it an Oscar?
Yeah.
Okay. So we're gonna derive this piece first, but then I want you to notice something. When I'm deriving this right here, we're really only deriving this because 1 is a constant. It is 3 f prime of x. And then we keep the next one as it is. 1 plus g of x. And then what operation separated product rule? Plus. And then I keep the first piece. Uh-oh. I'm lacking room. And the next one, all I need is g prime of x. Now let's plug in the 1 that they want us to compute. So my 1 will be 3 f prime of 1, 1 plus g of 1, plus 3 of f of 1, plus 1, and g prime of 1. So let's find each component. We're finding f prime of 1, g of 1, f of 1, and g prime of 1. So when I find, let's leave a 3 alone. That's our coefficient. What is f prime of 1? 4. And then we have 1 plus, what's g of 1? 2. Plus, and then I have 3 times, what is f of 1? 4. F of 1? F of 1, I see 3. Plus the 1. And then what is g prime of 1? 6. And let's go ahead and compute that. That's going to give us 12 times 3 that I'm going to write out. The next one is going to give me, is that 10 times 6? Which is going to give us 36. plus 60. So our total is how many? 96. Boom. Okay, let's go on to number 7. So on number 7, it's asking us to find where do I have my horizontal tangents, positive slope, negative slope, and etc. And we'll see what that etc. is going to be. So let's look at the graph. It is given f of x. So I want you to go to all of your horizontal tangents and draw your horizontal line. So how many horizontal tangents do I have? 4. The first one is at A, C, E, and G. Are we good with that one? Good? Now let's find the positive slope. B is positive. Where else? H is positive. So B and H. And then how many negatives do I have? 1. D is negative. So we've accounted for every letter except which one? And this is called the what? So I'm going to say etc. is cusp at F. Okay, number 8. Red, let's read.
Wait, so what's the
These were all individually answered.
Let f be a function such that f of 2 equals negative 1 and f of 6 equals 8. Which of the following conditions ensure that f of c equals 0 for some value c in the open interval of c of f of c equals 0?
Okay, let's go ahead and draw this. It says at 2, we're at negative 1. And I'm going to put a dot right here. And then we have at 6, we're going up to 8. Let's put our dot. I would say we have to choose between B or C. Which one do you think is a better answer? B? So B is increasing. When I'm increasing, I can choose to put dots and increase. Does that guarantee that it's going to hit the x-axis?
No.
But instead, if it is continuous, as in I can connect them all the way through, is it a guarantee right there? Yep. So increasing could be any dot going up. Continuous has to make a line. So therefore, it has to be C. Okay, number 9. Jill, let's read.
The table below gives selected values for the differentiable and decreasing functions f and its derivative. If g of x equals f, f negative 1 x, what is the value of g prime of 3?
Okay, so this right here is telling me that they are inverses. Let's all write out they're inverses. Meaning that x and y value can change depending on looking at G or F. So in this case, first of all, y'all should have the inverse formula memorized, right? G prime of 3 is 1 over what? F prime of G of 3. So the first thing that I need to figure out is, what is G of 3? And then we have a big problem. Do I have anything on the table regards to the G?
No.
But if I look at this guy right here, it says I have 7, 3. That will be for the f of x. For g of x, because they're inverses, I could swap them and say 3, 7. So do I now have g of 3? Yes, I do. 1 over f prime of 7. And then do I have f prime of 7? 1 over what? Boom.